Thank you everyone for joining once again. Very nice to see a lot of you, Portia, Randall. I will insist on video camera being on for a picture in a bit, but you're free for now, Chris. So Linda, PhD, of course, is a founder and CEO of Vantage Precision Health. And before that, she was Chief Data Strategy Officer at Ammon Labs, where she scaled an AI analytics platform across 150 behavioral health clinics. This introduction is coming from Aisha, and so what Aisha thinks is wild, and I completely agree, is that she started out as a neuroscience researcher at Harvard and Cornell, publishing 8 first author papers in journals like Nature before ever touching healthcare AI. So the person who's
Oh,
about to
I've
talk,
published over 40 papers,
oh, there we go, over 40.
just to eight in the last few years.
She used to study the human brain before she started figuring out how AI should get deployed across hospitals. So with that, Linda, the mic is all yours. Thank you very much. We will, I promise, end on time, everyone. I think that's one promise I make, because people need to hop off. So hopefully we'll have the last few minutes for questions. But with that, Linda, it's yours.
Okay, fabulous. Can you see my screen?
Yes.
Yeah.
Yeah.
Okay. Hi.
Yes.
So thanks to all of you for coming today. And we'll be talking about AI scribes. And there's a particular under-recognized problem with them, which is that when patient speech is ambiguous or when there are prosody or
Please.
tone. So this under-recognized problem is that when the patient physician dialogue is ambiguous or contains, let's say, prosodic signals that that aren't captured necessarily in the scribe clinical note, or aren't captured in the transcript from which it's going to make the clinical note. That information is compressed out, and sometimes overly literal interpretations result. Sometimes it's omitted from extremely important information, like expressing suicidal ideation is filtered out. So let's get into this. The main thing I'll do is briefly describe the problem, and then we'll look in detail at the scribe pipeline and how these errors result and what can be done about it. So physicians physicians and other clinicians love AI scribes. And they feel like they really lower their workload. And thus, as you can see here, they're scaling really rapidly. So this is their growth from 2023 to 2025, and then their projected growth through 2033. And you can see the almost exponential rise. So there's a severe clinician documentation burden. I don't know if you knew this, but clinicians spend an average of, for example, primary care physicians, of almost 6 hours a day in the patient's EHRs. They're not seeing patients. They're writing clinical notes about the patients and their visits and their prognoses, their prescriptions, their lab tests, and so on. And they're ordering things, etc. They spend a great deal of that time doing these clinical notes documentation of the patient visit. And so what AI scribes do for physicians, and I want to add, they do a lot of this after hours. So clinicians take these home and do them in their PJs, and that's when some errors can creep in. So AI scribes were meant to solve that problem for physicians by taking an audio recording of the patient visit and then turning it into a draft clinical note, which the physician will review and then approve, maybe edit first. And he or she takes responsibility for it legally. But scribes tend to generate other mistakes than physicians do. It's kind of interesting. But these have paradoxical benefits to clinicians. So they only save them an average of 5 to 35 minutes per day on this clinical documentation. But I think it's because they really like reacting to something and just having to edit it slightly rather than generating the whole thing de novo. Clinicians typically see 20 to 30 patients a day. And so this is a lot of clinical notes to write. So in most fields of medicine, the main clinical data are fairly objective. They're blood tests, they're medical imaging, and so on. But behavioral health is different in that the primary clinical data is language. And so AI scribes, even though they're scaling really widely across almost all medical specialties, their accuracy has not really been tested much at all in behavioral health. Most of the testing has happened in primary care. And the few behavioral health studies that have been done have been on not true clinical vignettes, but like Reddit excerpts of psychological discussions on Reddit. And in these more objectively based fields, AI scribe accuracy is similar to that of humans, so they are pretty good. In behavioral health, the few studies that have been done show that it's more problematic. And in particular, they have difficulty with ambiguities and paralinguistic. That's the non-language part, the tone, intonation, and so on. Paralinguistic cues. So as you can see in this example, the patient might say, I just don't feel like being here. And that may be indicating suicidal ideation. But the scribe might output that the patient reports low energy, or it just might be filtered out because the scribe decides it's not relevant to the clinical picture. Another example is, I only drink when I'm stressed. And if someone says that, especially if they're drinking at home, they really could be understating how much they drink, how often they drink, or how much they drink, or both. But the scribe might output, patient reports occasional drinking. So that's a literal interpretation of I only drink when I'm stressed, unless they're stressed every day. Any questions so far? Okay. So now, why?
Quickly, Linda, is your talk specifically about behavioral health and scribes, or is this going to be generalized?
This is generalized. They're just starting to be scribes on the market for behavioral health, and they haven't been put through independent studies yet. But this problem is also relevant to things like palliative care and oncology. Someone might say, I don't know if I should be spending the rest of my good days like this. They're on chemotherapy, they have metastatic cancer, and they're saying, gee, maybe I don't want to feel crappy from the chemotherapy. I'd rather just shorten my lifespan but have quality. Did that answer your question?
Yeah, okay. So you're any place where there's a behavioral aspect.
That's right. That's right. Any place where there's ambiguity in the speech. So like that oncology example might indicate that the goals of care should be revisited. If you interpret it literally, though, it's hard to make sense of. I don't know if I should spend the rest of my good days like what. So why do these errors happen where ambiguity gets over literalized And sometimes clinically important information is omitted altogether when it's ambiguous or it's of a paralinguistic nature. So here is the typical sequential scribe pipeline. So the first several stages are speech and signal processing. The speech segment goes in, there's audio capture, and then automatic speech recognition takes place. And just briefly, the speech signal is digitized, and then you run a Fourier transform, it gets tokenized. There's a whole series of predictive stages where machine learning will sort of predict what sound is likely to come next or what word is likely to come next. But anyway, that generates sort of a raw transcript of words. And then speaker diarization is who said what, determining did the doctor or the patient say X. And then the last stages, and again, these are typically serial, and this is a big part of the problem, as you'll see. So the LLMs, or usually a series of LLMs, will first segment the utterance. So it's different from tokenization in that now the language is being segmented into things like phrases and whole sentences and whole paragraphs. And then there's clinical abstraction, where it's determined what is the clinical meaning of each of these phrases or sentences. And then at relevance filtering, things that are deemed not clinically relevant are filtered out. And then what's left goes into a running note. And I should have said that this starts just on one segment of the recording. So the running note will be composed up to however many speech segments have been processed. Then you go to the n+1 speech segment. And at the end of the recording, you have a draft note. So I want to add that scribe architectures do vary, especially some of the newer models. And so I don't mean to say that every single scribe does it this way, but this is very common. So now we're ready to see where these errors creep in. So, so at audio capture to the utterance segmentation part, there can be capture errors like misheard words, the wrong speaker was identified as speaking, there's lost affective information, there's lost pauses. Sometimes with ASR, timestamps will be given to each sound. And then you can reconstruct long pauses, stuff like that from them. If this were done not from a transcript, but from the whole audio, then you can imagine a lot more of this information could be recovered. Anyway, so after capture errors between utterance segmentation and the clinical abstraction, where the scribe is trying to figure out, sorry that I'm making it sound human, but there are interpretation errors. So indirect or ambiguous meaning can be interpreted too literally at this point. And so that's like the I don't feel like being here is patient doesn't want to be at appointment. Okay, so then at the next stage, relevance filtering to creating, to building up the running note. Compression errors can happen where uncertainty is flattened. And something I neglected to say earlier is that these scribes are trained to produce clean, concise, pithy, short notes, summaries. And that is a part of, since they're optimizing that, that contributes to dropping things that it's uncertain of, or that it doesn't interpret properly and makes it more benign than it really is. So between abstraction, where it's decided what each sentence or phrase means clinically, then you go to relevance filtering. What is clinically relevant? And a lot of important information can be dropped there. And then I want to add, there's a fourth kind of error. By the way, my collaborator, Steve Davis, and I identified these classes of errors. So these context updating errors, because it's serial and because it operates speech segment by speech segment, it doesn't go back and interpret things in the larger context. And the running note is created in a completely feed-forward way. And then finally, at the end of the recording, there's a draft note. And what you would really want to have is flagged ambiguity, and information about like where there were long pauses or where the affect seemed flat. So you would want to preserve metadata, and sort of a secondary human review layer. But most systems don't do that. They just write you a draft of the note. And doctors are often doing this hours after they've seen the patient, making it less likely they're going to remember every detail and catch errors. So I just wanted to say at the end that these problems have fairly straightforward solutions. So first of all, there should be audio-informed note generation. That information should be captured somehow, or the note generation should take place literally from the digitized audio. And second, there should be ambiguity flagging, like I was saying. So if one of the LLMs wasn't sure what something meant, instead of dropping it, it should say that this is ambiguous and it might be meaningful. 3, there should be specialty-specific validation. So right now, there are very few standards for scribes. I'll say more about that in a second. And something that was validated in 2 studies in primary care shouldn't be used in oncology or behavioral health, right? You should use terminology and types of topics and ways of stating things that are specific to each medical specialty. And then finally, we need much more outside monitoring of these than we have right now. So you might know that the FDA regulates medical devices, but scribes aren't considered medical devices because they're considered administrative. And yet leaving out something that indicates suicidal ideation, or, and so on, that could really affect patients, and it's something that I think the FDA should monitor. And I think specialty societies, like in this case, the American Psychiatric Association, should be sort of generating the clinical things to consider, like what are the types of risks that are typically seen and how are they typically expressed, and so on. So that's all I have. I hope that was under 10 minutes or not much longer.
Yeah, it was just under 15 minutes or more.
Thank
Hi,
you,
Portia.
Linda. I was wondering, Two things. What type of context does the Scribe tools typically have? Your example about missing an ideation, suicidal ideation, could be potentially de-risked if the scribe had an indication that this is a person who has a history of suicidal, or at least they're kind of monitoring the high risk if it's an oncology patient. That's the one question. And then the second is just, especially in behavioral health, there's just so much open-ended dialogue that happens. It really, when you mention that scribes aren't really regulated that well, it really gets me to thinking about the implications of PII, other folks' personal information being shared because it relates to this person's treatment, and how, kind of like with all these scribes popping up, what is the inherent risk for data breaches that could be pretty detrimental to people, because behavioral health is a very sensitive space.
So to answer your second question first, these all take place within highly enclosed spaces, usually in the cloud, and they're just as HIPAA protected as everything else about the patients in their EHR. So that's not like an extra concern. But what is concerning is your first question. The context is not given in general. So the scribe doesn't even know this is a psychiatric practice. Or maybe current ones do. Maybe there's a problem in that it takes about a year to do a study and publish it. So we're about a year behind in evaluating these scribes. But no, it just goes speech segment by speech segment. And then whatever they're trained on, they learn some context from that, obviously. But if it doesn't include behavioral health, then like you said, those really open-ended, hard to interpret phrases might not be part of its repertoire. Next person.
That's me, and I'll go. It's a great, thank you for the talk. I'm curious about your clinical validation. So when AI is doing summary, AI is doing any kind of action there that changes the information a clinician has, that ends up becoming a step into kind of clinical decision support practices and other elements. Can you talk to me about how you've gone about navigating that? What are you comfortable doing before you do the level of study and rigor that's necessary for the type of clinical decision in an automated fashion that's required, and how do you draw that line back to delivering value, learning more, and trying to stay on the right side of compliance?
Interesting question. So the main thing that I would say to that, since we're short on time, is that the clinician is liable for all of this. He signs it, and he's supposed to catch those issues in his review. But as far as things like compliance go, these things usually live inside the EHR, and they're not monitored any separate way from what else lives in the EHR.
Okay. No, I don't have any questions. So Keith, all over to you.
Thank you, Linda. That was actually pretty interesting. When I looked at the 4 problems you outlined, I'd say the first 3 are engineering problems within the scribe. They may not be easy, they may not be cheap, but they're engineering problems within the scribe. The 4th one is a little different, this notion of context, and this happens to be a particular, as because we've spoken about this, that this notion of context and a place for context in the clinical world doesn't currently exist. It's a class of information that systems of record like EHRs are not designed to contain. And so to really do this right, you need not only to build a context over the course of whatever you're recording, which, is still over time, but also to have the context of the patient, to have the patient modeled in a way that you have a contextual model of the patient. So you know that for this patient, this kind of conversation might indicate a shift towards suicidal ideation.
Right.
You'll only know that if you build a contextual model. And as I say, the current clinical universe has no place for that. And that's outside the scribe, so to speak.
Yeah, so can I just really
go
quickly?
ahead. Yeah.
Yeah, like I feel like I wrote this in the chat. I feel like we're veering into a non-scribe like environment, like more a clinical decision support, like
Yes.
symptomology, diagnostic.
Right.
And so it's like
a form of data management or information
But
management.
let me just add, Keish, some of the context could be solved with engineering, right? So there could be feedback loops where you go back and reintegrate, you review what's currently being said based on what was said, and minus
context within the scribe. You could build a limited context within the scribe. It's a different,
and then you can build up context in the model in its training. So at least it will be savvy about behavioral health. But you're right. So you're making a really interesting point that you don't think anywhere in the EHR there's something capturing this is patient X, their diagnosis is Y, they've had these problems in the past, et cetera.
And linking them up in sort of a knowledge form, in an ontological form that doesn't exist because EHRs were never designed for that. So yes, you could build it all into the scribe. To me, it would be a shame to build it all into the scribe because it has so many ramifications outside the scribe. But that to me is a big piece of what's missing here.
That's really, really interesting. I'd love to talk with you more, and we should found a company.
We can talk about that. I have some notions. I'm doing some things around that. So,
any other?
Tao?
Anybody else who wants to talk about that?
By the way, am I pronouncing your name right?
Oh, yeah, that's right.
Yeah. Okay, please go for it.
Yeah, Linda, good to see you. I think last time we spoke, it was last fall, I believe, or the late summer. Yeah.
You had a really great idea for a financial services AI company.
Yeah. So I'll catch up with you on the offline, kind of to bring up to speed on some of the areas. But I was curious about, I didn't catch everything, but I probably caught kind of the later half of your presentation. You mentioned Fourier transformation and doing some sequential modeling. So are you folks leveraging some LSTM, long short-term memory-based kind of the convolutional neural network and those kind of models? And if you are doing, like, a lot of these models are prognostic, kind of predictive in nature, like what is the regulation, governance, and behavioral accuracy and all those things? I'm like curious from, I know some of the other
That's just a small, easy to answer question. No.
Okay.
Typically in ASR now, there are encoder-decoder models and transformers. And so there is a lot of like look back within that module. But for some reason, the engineering hasn't been built right now to review more of the phases together. And to review the running note based on new information. I wasn't quite sure what you meant about compliance.
No, I mean the accuracy and kind of the impact of the model, how you use it to make some decisions. It's either assessing behavioral health and etc. So like you mentioned the clinical things, right? So being a statistician,
these are used in about in more than a third of clinical practices across cardiology, gastroenterology, you name it. If they ask if they can record the visit, this is why, because they're having an AI scribe, make the clinical note for the doctor.
All right, you answered my question. Thank you, Linda. Yeah.
I now have a question. So
yeah.
So Keith, this is for you and Linda, but And this may be a silly question, but I believe there are no silly questions. The context problem that you spoke about, I feel like it's just like given my conversations with both Claude and ChatGPT, I feel like it's just about giving it the right prompt to be aware
So how do
and
you build that prompt?
interpret.
How do you build that prompt? How do you build the context window? So the word context gets overloaded. So how do
Yeah.
you build the context window that you're going to give into the LLM? You need a data model outside of it that is bigger, that that is mapped in a relationship way, not in a system of record kind of way. And then yes, at that point if you have the context, you can extract from the context the piece of the context that's relevant to the current query.
So I don't get it. So all it will take is a simple prompt that, hey, take the role of a XYZ psychologist. Is it a recording that they're scribing from? You give the entire recording.
Context is
Preet,
outside the
humor
context.
me. I think this will work 80% of the time. I'd love to run an experiment. It'll be better than what the scribe did over there in terms of the person doesn't want to be here. Like, uh, there's a reason people have an emotional connection with AI, and there are many successful companies out there. No, I'm just putting that out there.
I think
We can take this offline and talk about it some more. You won't get as far as you think by some clever prompt engineering.
Okay.
You can get a little distance, but when I have a conversation with ChatGPT, for example, that actually feels like it's responding to me, it's because I've built a context in the context window over pages and pages of exchanges, which goes away in the very next session that I start. It's gone.
If you were one of those
Not
doctors,
anymore. It remembers across
Albert
paths.
and Tao, just feel free to jump in. At this time, it's everybody.
Well, so I think like Linda, just really good job, really interesting. I learned things that I didn't know from your initial paper. The one question I have is, and it relates to the context window is it, and I'm not an expert in the scribe area. Is this even what scribes do? And I'm talking about human scribes. So like I know that human scribes are generally low level staff members who are like right out of college. They're low cost and low training. And so like it doesn't really make sense that cognitively they would even have the ability to interpret in the real world context, like those complicated things that you're mentioning, to actually link it
And
to
they
such
might get
stuff.
better through feedback, but you're right. You're absolutely
And
right.
so,
They come onto the job without special expertise.
yeah, and so I guess like, is this even a problem? Like the things that you're bringing up, like some of them, like for sure, like the leaving out, uncategorized speech or whatever, but you could solve that with like raw transcripts, like just keep all raw transcripts in a database of the actual recording, and then you could go back historically to look at the raw content, raw transcript.
When the family is suing for wrongful death.
Yeah, but I mean, you so like what I guess, yeah, let's
It's
leave it
not going to
at, is
happen.
this even what we should be asking of AI scribes? Because like that's why I brought up like this seems to be moving into diagnostic
Yeah.
specialist area.
I just to answer the part about the context, it's strange to me I understand why they were originally done serially like this, but it seems strange to me that there isn't a broader picture at the whole note stage that can go back and check the record. And then Keith, correct me if I'm wrong, but I believe the audio recordings and the transcripts are available to physicians in a lot of cases.
All of these detailed pieces of information are kept somewhere, but nobody ever looks at them. Think about what happens when you take an MRI. When you get an MRI, I had this experience in the last couple of years. An MRI that is this incredibly rich, detailed image, right? Immense amounts of information, and one piece of information is extracted from it because that's the current mission, and everything else is kept somewhere, and it might be looked at if people are sued, but it's never looked at again clinically because there's no place for extracting the relationships and information and storing them, what I call context, right? So you're right. This isn't the job of even a human scribe. Human scribes produce a system of record notes, and they lose all kinds of things.
Yeah.
But it's a problem in general because nuances are lost, and those nuances are essential.
So this is a very prevalent issue, Keith, in every industry, and that's where this is a very prevalent issue in every industry. This whole context engineering, what you are describing, actually semantic layer and ontology. That's why you use the data.
I absolutely agree. I've had the same problem in industrial contexts, right? But at the moment, I happen to be focused on the healthcare context personally, and I think it's an enormous problem for the healthcare industry.
Yeah.
What do you think about world models and models that are going to be developing, conceptual understandings? Yeah, I assume that's going to be.
They can't be individualized. That's the problem with these world models, is that they're a generalized world model and they do a better job. If you look at something like a JEPA-trained model or the world models that, Jan LeCun and all those people. I didn't mean to take this over, so we probably should take this offline.
No, but you have a lot of relevant knowledge, so it's okay. It's okay.
This is a world model that is a model of you. And again, even in the industrial world, it's a model of a machine, for example. And how do you keep all that nuance for what's going on in some complex machine? It's a similar problem. Humans are even more complicated, and they happen to matter more to other humans.
And with that, thank you everyone so much. I'm so sorry we've taken 1.5 the amount of time we were supposed to, but Linda and Keith, thank you so much.